All right, welcome back. So we're gonna dive right into chapter 9. This is on cloud computing. I did want to do a quick go over the on my personal blog here. I looked at self-learning methods, some of the pros and cons of each, and there was one self-learning method I had here that I think I wasn't really quite clear about. When I'm talking about this, I'm talking about paid in-person classes, such as at a college or a university or something like that. So let me make that clear. Paid in person. All right. So there's an alternative to that, and the alternative would be a unpaid, not in online class. So there's all kinds of options for that. There's Coursera, there's edX, and these are free, world-class, world-renowned courses that. Oh, what is this? Coursera? Is Coursera? Oh, what happened to Coursera? Oh, here it is. Yeah. So, uh, yeah, and then there's also something like is Udemy free? I don't know if Udemy is free. Um, yeah. So there's Udemy is another one. So yeah, these are all free classes. Right now, what I'm learning is Python DevOps. So here we go. Here's a whole. But this is not free. Why is this not free? This is not free at all. Okay, so forget about Udemy. Screw it. If you go to edX though, and you search a class, so let's see. It gets a little tricky too because okay, like this introduction to Python programming, like just go read the book, learn stuff the hard way. Like I'm gonna go back to my blog here. I'm gonna try not to spend too much time on this. I want to dive into chapter 9 as soon as possible, and I need a drink of water as I'm talking here. Yeah, this thing here is just so nice because it's all free, it's all out there, it's all ready to go, and the con, is the quality. But to be honest, that actually might not be a guarantee. It actually might be more difficult to a lower quality to learn from like an institution like MIT. Just because it's got the MIT branding doesn't necessarily mean, or the Harvard branding doesn't necessarily mean that it's the best possible resource. It's probably a good chance of it being a high quality resource, if not the best possible available resource, but it's yeah. So this is a really good one. CS50. Can definitely vouch for the high quality of this. And if you're young watching this video, you can get AP experience and use this course to prepare for your AP exams and get free college credit. Now, what you'll see here is a price tag. So this price tag is optional. If you choose not to pay the price tag, then you click I'm interested. You go down here. You don't need to receive the emails, and you say pursue the program. You'll need to log in. I'm logging in with my Google account. Oh, okay, it didn't fill in my credit card information, but what the hell? Now, why is this not working the way I thought it would work? See, I thought it would. I thought it would work differently than this. Like I thought. Let me see here. Okay, I'm really confused because I thought this was. Oh, you can only take it if you're in high school and you have to pay for it, I think. That's stupid. Oh, that pisses me off. That's God damn it. I'm sure it's high quality, but like come on. I mean, I guess it makes sense because they don't want like they're using this test to like vet out students. Um, so like they don't want just anyone to have access to the test. Then they'll just have people memorizing the test and getting in just because they had special access to the test and not because they actually know any of the material on it. But okay, this is more what I was expecting to see here. So you can take this Introduction to Computer Science. For some reason, if you want to learn about the intellectual enterprises of it and not just how to do it effectively. Um, so I don't. So yeah, now we can see uh, we still got a price tag on it, but you're only paying for a interaction for like a credential. So you skip the credential, you still get to learn all of the material, which is really the most important thing. Just to keep doing this sort of thing, learning stuff, because then if you want to change careers, you can get a credential a lot easier because you already had pre-exposure, some pre-practice with it. It's typically easier to learn something, to kind of brush up and get better at something than to learn it for the first time. Unless, of course, when you learned it for the first time, you completely learned it wrong and you have to unlearn things. Then it makes it harder, but I think for these sorts of courses, these are going to be pretty darn good. So I just wanted to bring that up. I was unclear about what I meant by classes. I'm, over. I'm not quite a boomer, but I'm almost there. So for me, a class is a in-person paid college or university, and I personally haven't really done anything like this all that much. But for somebody new who's kind of looking at how they want to learn, definitely check this out. I think this is a really, really good choice alongside these other choices. Purchasing books, and just going your own way based on the books you buy. Looking for free tutorials or books you just find for free online. Good example of this is Learn Python the Hard Way. This is the book that really made Python make sense to me when I very first picked it up, and this was like a long time ago before I even went to networking school. I kind of learned Python a little bit because it was like trendy. And this is definitely the best. Like I didn't have anything I needed to do that used Python. I kind of wish I had like made a video game or something, but okay. So yep, I just wanted to make that clear. And you know what? I am gonna add this. So um, unpaid online. So let's think of some pros for this. We're going to say and this is just what I believe. I don't really know. I haven't really done these, so I'm definitely not a good resource for this, but this is just kind of what I think. And I'll definitely, if I start to as I start to work through this, I'll probably come back to this and update this because I'm not sure. But I would think a pro of an unpaid online class is you probably do get classmates. And I'll put question marks at the end of these because I don't even know. Free, that's definitely a pro. And then completion time expectations. Probably quality too as well if you're signing up for. Yeah, I guess I would say like quality because like. But I'll put a question mark against that because I don't even know. Cons. You know what? I'm going to put the boring lectures. But I'll put that with a question mark because, you know, as I said, I haven't really done these, but I would guess if they're offered by traditional institutions, they have a lot of boring lectures. And actually, I have seen a lot of the CS50 curriculum, and there were a lot of boring lectures. So boring lectures could be a con. Another con could be I don't even know. I'm just going to put question marks because this is kind of the big unknown for me. I haven't really dived into this sort of thing all that much. Okay, but let's keep going with the first self-learning method, which is going to be Amazon Kindle books. So right now I'm reading this book, Python for DevOps, and I'm on chapter 9, Cloud Computing. I'm going to read this first paragraph. I'm going to get some water and come back. Cloud computing is a term that creates the same confusion as other popular modern buzzwords, such as big data, AI, and agile. When a term gets popular enough, it eventually means many things to many people. Here is a precise definition. The cloud is the delivery of on-demand computing services where you pay for what you use, just like any other utility, natural gas, electricity, or water. That is a very precise and clear definition. So we will highlight that so I can come back to that. And I desperately need a glass of water, so I will be back soon. All right, the top benefits of cloud computing include cost, speed, global scale, productivity, performance, reliability, and security. Let's break down each one of these. Cost. There is no upfront cost and resources can be precisely metered to meet demand. Speed. The cloud offers self-service, so an expert user can leverage the services to build solutions quickly. Global scale. All major cloud providers have a global scale, which means services can be provisioned all over the world to meet demand in a geographic region. Productivity. Many tasks, such as racking servers, configuring network hardware, and physically securing a data center, no longer exist. Companies can focus on building core intellectual property versus inventing the wheel. Oh, why don't you have to do that? Oh, because you're paying someone else to do that? I guess that makes sense. You're outsourcing that. Performance. Unlike because it's not your own hardware. Unlike hardware you own, cloud hardware is continually upgraded, meaning that the fastest and latest hardware is always available on demand. A lot of the hardware is also joined together on low latency and high bandwidth infrastructure, creating an ideal high performance environment. So an example of something that's not cloud networking is my lab that I've been using here, which I don't have SSH on my computer apparently. So I have to open if I open this, and then do SSH, 168.1. So here's my lab. I don't even know what my password is, honestly. Oh, it's that. So this is my lab. Yeah, running 18.4. And this is a server I bought from SaveMyServer.com. This is what runs my GNS on it, but I can, yep, this is my GNS server. I reach out to that and I can do all sorts of things with it. Very nice. But that is not an example of cloud computing because I have this kind of noisy giant thing in my apartment that it's limited to what it can do. So this is it, I loaded it up with the options I selected at the time, which now I would probably choose a little bit different options. But if I had gotten a cloud service instead of this, it doesn't matter. It wouldn't have mattered at all the options I chose because I would just be getting what they provided to me, and hopefully they'd be providing me the things I need. Otherwise, I wouldn't be using the service anymore. So this is an example of getting a networking lab without using the cloud. So if you wanted a networking lab through the cloud, there's something called Cisco Viral. So when you pay for Cisco Viral, you get to use hardware owned by somebody else. That's an example of a cloud service. Whoa, that's kind of cool. Do I have to pay for this? Yeah, but here's another yeah, so I think this is another, I guess I want to say this is a cloud service. I mean, it looks like it's just a training for a cloud service. I'm not sure if it's a cloud service itself. But this looks like a cool course. Oh, I'd have to, okay. So this is Coursera is a monthly trial. It's not free. Damn it. Oh, foiled again. Why am I always foiled? Alright, whatever. I have my own server, so I can do whatever I want. Like, they'll just slow me down. Okay, okay, so reliability. The core architecture of the cloud offers redundancy at every step. There are multiple regions and multiple data centers in each region. Cloud native architecture can design around these capabilities, leading to highly available architectures. Additionally, many core cloud services are themselves highly available, like Amazon S3, which has 9 nines, which it does not include the first 2 nines. So there are 9 nines here, and there are 11 nines total in this number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nines in total. 1, 2, 3, 4, 5, 6, 7, 8, 9 nines after the decimal. So when they say 9 nines, they mean the number of nines after the decimal. Security. You are only as good as your weakest link with security. By consolidating to centralized security, a higher level of security occurs. Problems such as physical access to a data center or encryption at rest become industry standard on day one. Cloud computing foundations. In some ways, it is hard to think about DevOps without also thinking about the cloud. Amazon describes the following as DevOps best practices: continuous integration, continuous delivery, microservices, infrastructure as code, monitoring and logging, and communication and collaboration. Of these best practices, you could argue that all of them depend on the cloud's existence. Even the harder to define practice of communication and collaboration is made possible by a modern suite of SaaS communication tools: Jira, Trello, Slack, GitHub, and others. Where do all of these SaaS communications tools run? In the cloud. And that I will speak to. One of the most valuable collaboration tools I have used is Slack, because when you're on calls, you can draw on somebody else's screen right away. So you can kind of prove that you're paying attention. If you see something, like, you can underline it, and you don't have to waste time saying, like, on the right hand side of the page, this, the other person's like, what do you, I can't tell what you're looking at. You just draw it on the screen. Communication tools make a huge difference. What is unique about the modern cloud era? There are at least 3 defining characteristics: theoretical infinite computing resources, on-demand access computing resources, and no upfront commitment of capital. Hidden inside these characteristics is DevOps skills, Pareto distribution. So I think I know what Pareto distribution is. Do I? I think I do. So I think what a Pareto distribution is, I don't know what I think it is. Yeah, I don't know what that is. I know there's like a Pareto efficiency. Oh, no, it is a Pareto. Okay. Yeah, I know what a Pareto efficiency is, but I don't know what a Pareto distribution is. A Pareto efficiency is basically like a situation where So something that is not Pareto efficient, from what I understand this concept means, and I could be wrong. I'll skim the Wikipedia article after I give this explanation. But my understanding is that a situation that is not Pareto efficient is a situation where you have elements where some elements are better than other elements, but if you took the elements that were worse and you took away from the elements that are better, some of the things that make those elements better, the elements actually wouldn't get any worse, despite having some things taken away from them. And then those things could be given to the worse elements to make them better. So you have a whole system that is better now because the elements that were already the best elements are functioning just as well, if not better, because now they don't have the extra stuff they don't need. And then the ones that don't have as much success are now helped out by these extra resources. And Pareto efficiency is a system where you can't do that. Everything is already perfect, and doing anything like that would decrease the total efficiency of the system. So you want Pareto distribution to occur, because otherwise you have elements that are just struggling for no reason, and elements that are just so wealthy that the wealth is basically like a weed or an accumulation, or like undesirable at some point because there's just too much. They don't even know what to do with it. So let's see if I'm correct about that. Yeah, there's an easier way to say it. So it's an exchange whereby an individual or preference criterion cannot be made better off without making at least one individual or preference criterion worse off. That's a Pareto efficiency. So when you have something that isn't a Pareto efficiency, you can make individuals or whatever have you, elements in the system, better without making any other element worse. And you can imagine, if that's possible, oh my God, that's a horrible situation. Do it, like do the thing, make the whole system better by making the poor performing systems better without affecting or even possibly improving the already superior elements. But a lot of economies, a lot of societies choose not to do this and just choose to operate in Pareto inefficient environments, and that's a reason for dysfunction. Oh, okay. And it's a little bit because it's a mathematical equation for like engineering systems. So like it's a little bit wrong to say like if you're thinking right now, tax the rich and give it to the poor, that's not what a Pareto efficiency is designed to do. It's really not for that sort of thing. It's like an engineering like equation. It's not about like the economy and money. Those are all like really more complex values than this equation is designed to take in. Yeah, and it's complex. So it's not as simple as tax the rich, because it could be that by taxing the rich, you make your system less Pareto efficient, because those taxations uh, affect the targets in such a way that the whole system suffers. So it's it looks like it often is used to like understand economic and societal concepts, but it looks like that's um, a little bit beyond its use, and it looks like it's most commonly used in to study biological processes, to I guess microeconomics. Um, yeah, microeconomics uses it a lot, but like taxation and stuff, that sounds like more like macroeconomics. But anyways, I guess I from that believe now that I kind of understand it, but I really don't understand it. I don't know what any of these equations mean. All right. Yeah, so this is what you want to know what a Pareto efficiency is. It's this until you can't do that anymore. So it's a complicated concept. It's just not super easy to give a clear and concise answer to. But that other article, I think, did have one. All right, so I'm going to update this. All right. In practice, the cloud becomes incredibly cost-effective when used in a manner that supports the real efficiencies of the cloud. On the other hand, for unsophisticated organizations using the cloud, it can be incredibly expensive because they are not taking advantage of the core features of the cloud. And that's why I decided not to go with that, because I did find a system where you can like rent a lab and stuff like that, but I didn't want to rent a lab. Like I wanted to own my own lab, and so like I didn't. So there's reasons not to use the cloud. It is probably fair to say that 80% of the gross profits of the cloud in the early days were derived from unsophisticated users who left instances idle. Wow, 80% chose the wrong instances, too big, didn't architect for auto scaling. So the cloud is just a giant scam to bleed money from unsophisticated users, or used software architectures that were non-cloud native, such as shoving everything into a relational database. Likewise, the remaining 20% of gross profits were derived from incredibly thrifty organizations with exceptional DevOps skills. Before the cloud existed, there was a fixed cost that never went away. The cost was fixed both in terms of money and in developer time. A data center had to be maintained by a team of people, and that was a full-time job and very expensive. As the cloud has grown in maturity, only the best of the best now work in data centers. And they are working for incredibly sophisticated organizations like Google, Microsoft, and Amazon. It isn't statistically possible for a small company to have the hardware talent of a data center engineer at that level, at least over the long term. A fundamental law of economics is the principle of comparative advantage. Instead of looking at what the cloud costs and thinking that you can save money by doing it yourself, look at the opportunity cost of not doing something else. Most organizations have concluded that, one, they cannot compete at the level of Google, Amazon, and Microsoft in data center expertise. Two, paying for cloud services allows the company to focus on other areas where they can use their unique skills. Netflix has decided to focus on delivering streaming services and creating original content, than I think they meant rather than. I guess that is hard to read. Rather than running its own data centers. If you look at the Netflix 11-year-old stock price from 2008 to 2019, it is hard to argue with this strategy. What is unique about Netflix, though, is its dedication to operational excellence in the cloud. Current or former Netflix employees have given numerous talks at conferences, developed and released tools on GitHub, and written articles and books on DevOps and cloud computing topics. This further supports the point that it isn't enough to realize that the cloud is the correct device, but this decision must be backed up by operational excellence. Otherwise, an organization risks being the equivalent of a gym member who signs up for a year membership yet only goes for 3 weeks. The members that don't go to the gym subsidize the cost of the gym for the other members who attend regularly. Alright, I need another glass of water. I'll be right back. Okay, I'm back. Types of cloud computing. There are several main types of cloud computing. Public cloud, private cloud, hybrid cloud, and multi-cloud. The majority of the time when you hear about the cloud, it is about a public cloud. It isn't the only type of cloud, however. Oh my god, I am freaking out. That I can't handle that. I seriously, I can't. Like, I'm a programmer. Like, I write code. I can't deal with this. This book is obviously not written by or written for programmers. Oh my god. Oh. Oh. Okay. Alright, moving on. A private cloud is used exclusively by an organization and is either physically located in that organization's data center, or it can be hosted for an organization by another company. Some examples of private cloud providers are HPE, VMware, Dell, and Oracle. A popular open source private cloud option is OpenStack. An excellent example of how that could look in practice is that Rackspace, a more niche alternative in the hosting space, is one of the largest providers of OpenStack private clouds as a service. And let me be very, very clear when I say I'm a programmer and a sentence like it isn't the only type of cloud, however, bothers me because because of that, because I do programming. I'm not saying that any little typo or bad sentence or whatever like that would drive me crazy when I'm programming or when I'm working with code in a professional environment. What I'm saying is that this book has been published, vetted. They're selling this book for money. I'm sorry, like if you ship code and it has something like that in it, that is just not cool. Like, yeah, if you're editing it, if you're doing it for the first time, it's a rough draft, it's gonna happen. But to make it this far in the process and have a sentence like that, that's what I mean when I say I can't handle that because I'm a programmer. Like, the code's gotta go vroom. If it doesn't go vroom, then that's the biggest issue for me, and to have it get this far without going vroom is a big deal. All right, a more flexible option is the hybrid cloud. The hybrid cloud combines both a private and public cloud. An example of this type of architecture involves using the public cloud for situations that provide scalability and extra capacity, and using a private cloud for day-to-day operations. Another example could involve a specialized hardware architecture, say a farm of GPUs that perform deep learning in a private cloud, and the connected public cloud serves at the core infrastructure. Even major cloud providers are entering this space. A good example is the Athos platform from Google. This platform does the hard work of linking an on-premises data center with GCP to allow workflows such as running Kubernetes clusters in both locations in a seamless manner. Finally, MultiCloud is a choice that is enabled partially by modern DevOps technologies such as Docker containers and IAC solutions such as Terraform. A multi-cloud strategy is one that involves using multiple clouds at the same time. An excellent example of this is running jobs in containers on multiple clouds simultaneously. Why would you do this? For one reason, you could decide to run jobs on AWS spot instances when the price was suitable to make a profit, but on GCP when AWS was too expensive. Tools like Terraform allow you to abstract away cloud concepts into a familiar configuration language, while containers allow code and an execution environment to travel to any destination that can run a container. Types of cloud services. There are 5 main types of cloud services: infrastructure as a service, IaaS, metal as a service, MaaS, platform as a service, PaaS, serverless, and software as a service, SaaS. Each of these cloud services works at a different layer of abstraction and has pros and cons. Let's break down each service. Infrastructure as a service. IaaS is a lower level category that includes the ability to rent virtual machines by the minute, access object storage, provision software-defined network, SDN, and software-defined storage, SDS, and bid for an available virtual machine. This level of service is most closely associated with AWS, especially in the early years, 2006, when Amazon launched S3 Cloud Storage, SQS, Simple Queue Service, and EC2 virtual machines. The advantage of this service for an organization with strong expertise in DevOps is that it can be incredibly cost effective and reliable with a small team of people. The disadvantage is that IaaS has a steep learning curve, and when administrated inefficiently, it can be expensive in terms of cost and human behavior. In the Bay Area during 2009 through 2019, this scenario played out in real time on AWS at many companies. One story that brings this home occurred when Noah ran engineering at a SaaS company that provided monitoring and search tools. During his first month on the job, there were 2 mission-critical problems involving the cloud. The first problem, which occurred during week 1, was that the SaaS billing system misconfigured the storage system. The company was deleting data from paying customers. The gist of the problem was that they didn't have the necessary DevOps infrastructure needed to succeed in the cloud. No build server, no testing, no real isolated development environments, no code review, and limited ability to deploy software automatically. The fix Noah implemented were these DevOps practices, while a figurative raging fire burned. Note, a developer did set fire to the office by cooking bacon, what the hell, in a toaster oven. Noah thought he smelled smoke, so he walked into the kitchen, and flames were crawling up the walls and the ceiling. Fire extinguisher, now. He was so stunned at the sheer irony of the situation that he sat there for a few seconds soaking it in. Fire extinguisher, now. Like, you should probably like anywhere you go, if you're going to be there like for a while, like work there, look like just look at where the fire extinguisher is, like before there's a fire. Fortunately, a quick thinking coworker, his product manager, grabbed the fire extinguisher and put out the fire. Aim at the base of the flames. A second, more serious problem with our cloud architecture occurred shortly afterward. All of the developers in the company had to be on call so that there would be 24/7 coverage, except the CTO/founder, who often wrote code that was directly or indirectly responsible for outages. More on that later. What the heck? One night when Noah was on a call, he was awoken at 2 a.m. by a call from the CEO/founder on his cell phone. He told Noah they had been hacked and that the entire SaaS system did not exist anymore. There were no web servers, search endpoints, or any other virtual machine running the platform in existence. Noah asked why he hadn't received a page, and the SEO said the monitoring system was also deleted. Noah decided to drive into work at 2 a.m. and work on the problem from there. As more information surfaced, the issue became apparent. The CEO and founder had set up the AWS account initially, and all emails about service interruptions went to his email. For several months, Amazon had been sending him emails about how virtual machines in our region, Northern Virginia, needed to be retired and that in the coming months they would be deleted. Well, that day eventually came, and in the middle of the night, that entire company's servers ceased to exist. Noah found this out as he drove into work, so he then focused on building an entire SaaS company again from scratch, using the source code in GitHub. It was at this point that Noah began to understand both the power and the complexity of AWS. It took him from 2 a.m. until about 6 p.m. Wow, 6 hours, that's pretty good. To get the SaaS system operational and able to accept data, process payments, and serve out dashboards. It took another 48 hours to completely restore all of the data from backups. One of the reasons it took so long to get things running again is that the deployment process was centralized around a forked version of Puppet that a previous employee created but never checked into version control. Fortunately, Noah was able to find a copy of that version of Puppet at around 6 p.m. on one lone machine that survived the carnage. If this machine hadn't existed, it might have been the end of the company. It would have taken perhaps a week to completely rebuild a company of that complexity without some infrastructure as code, IAC, scaffolding. An experience this stressful that had a reasonably happy ending taught him a lot. Noah realized this was the trade-off of the cloud. It was incredibly powerful, but the learning curve was crushing even for VC-funded startups in the Bay Area. Now back to the CTO/founder who wasn't on call, but checked code into production without using a build server or continuous integration system. This person wasn't the villain of the story. It is possible that if Noah himself was the CTO/founder of a company at a certain point in his career, he might have made the same mistakes. The real issue is the power dynamic. Hierarchy does not equal being correct. It is easy to get drunk on your power and believe that because you are in charge, what you do always makes sense. When Noah ran a company, he made small, similar mistakes. The key takeaway is that the process has to be right, not the individual. I love that. If it isn't automated, it is broken. If it isn't going through some type of automated quality test control, then it is also broken. If the deployment isn't repeatable, it is also broken. One final story to share about this company involves monitoring. After those two initial cases, the symptoms resolved, but the underlying diseases were still malignant. There was an ineffective engineering process in the company. Another story highlights the underlying problem. There was a homegrown monitoring system, again, initially created by the founders, that on average generated alerts every 3 to 4 hours, 24 hours a day. Because everyone in engineering except the CTO was on call, most of the engineering staff was always sleep deprived because they received alerts about the system not working every night. The fix to the alerts was to restart services. Noah volunteered to be on call for 1 month straight to allow engineering the time to fix the problem. This sustained period of suffering and lack of sleep led him to realize several things. One, the monitoring system was no better than random. He could potentially replace the entire system with this Python script, which just gives you random monitoring in the middle of the night. Alright, how much longer we got to go? Oh, we've got a little bit to go. Let's get all the way up until that. Once he realized this, he dug into the data and created a historical picture of every single alert for the last year by day. Note that these alerts were meant to be actionable and to wake you up. From figure 9.2, you can see that not only did the alerts not make sense, but they were increasing to a frequency that was ridiculous in hindsight. They were cargo culting, engineering best practices, and figuratively waving palm tree branches at a dirt runway filled with airplanes built out of straw. In looking at the data, it was even more distressing to learn that engineers had spent years of their lives responding to pages and getting woken up at night, and it was utterly useless. The suffering and sacrifice accomplished nothing and reinforced the sad truth that life is not fair. I don't know if that's a truth. I don't agree that life is not fair. I think life is fair, but it takes effort and work to make it fair, which often does not get done. The unfairness of the situation was quite depressing, and it took quite a bit of convincing to get people to agree to turn off the alerts. There is a built-in bias in human behavior to continue to do what you have always done. That's the truth. Additionally, because the suffering was so severe and sustained, there was a tendency to attribute deeper meaning to it. Ultimately, it was a false god. The retrospective on using AWS Cloud IaaS for that particular company is, in fact, the selling points of DevOps. You must have a delivery pipeline and feedback loop, build, test, release, monitor, and then plan. Development and operations are not silos. If the CTO is writing code, they should also be on call. The pain and suffering from years of being woken up would serve as the correct feedback loop. Love that point. That is amazing. Yeah, because and they're going to be the ones who actually know how to fix it when there's an issue too. I'm highlighting that. Number 3, status, and this is the third selling point of DevOps. Status in a hierarchy is not more important than process. There should be a collaboration between team members that emphasizes ownership and accountability, regardless of title, pay, or experience level. Speed is a fundamental requirement of DevOps. As a result, microservices and continuous delivery are requirements because they let teams take ownership of their services and release software more quickly. Rapid delivery is a fundamental requirement of DevOps, but it also requires continuous integration, continuous delivery, and effective and actionable monitoring and logging. It provides the ability to manage infrastructure and development processes at scale. Automation and consistency are hard requirements. Using IAC to manage development, testing, and production environments in a repeatable and automated manner are the solution. Alright, so that's going to be it for this video. Thanks for watching, and I'll see you in the next video.